So today we are going to introduce exponential growth and decay. Some key terms that you will need to know are exponential, growth, and decay. Let's take a look at what each of these mean. Exponential means increasing or decreasing at a rapid rate. Next, growth is a function that is becoming larger, or a positive function. And lastly is decay. Decay means a function that is becoming smaller, or a negative function.
We are going to begin with discussing exponential growth. The equation for this is y of t is equal to ae raised to the kt, where a is the initial value, k is the rate of growth when k is greater than 0, and t is equal to the time. A real-life example of exponential growth is a bank balance. Looking at this graph, the balance is equal to 2e raised to RT, where r represents the k in the original equation and 2 is the a. R is equal to the growth rate in percent per year for the bank. When looking at the graph, you can see that it begins at balance equals 2, since at the initial time t equals 0, 2 is the initial value. Lastly, when the growth rate increases, the graph grows exponentially.
Next, we are going to discuss exponential decay. As you may notice, the equation is the same as exponential growth. However, let's see how the variables differ. First, a is the initial value, which is the same as before. Next, k equals the rate of decay, so k is less than 0, which will have a different impact on the graph. And lastly, t is the time, which is also the same as before. An example of exponential decay is the rate at which your heart recovers after a workout. Looking at the graph, you can see that the a value of the equation is your peak heart rate. Next, the k value impacts the rate at which you recover. If your k value is greater, then the graph decreases faster than if you have a smaller k, implying that you have a faster recovery time.
Now that we have introduced what exponential growth and decay are, Mrs. Colvin is going to dive into the subject a little bit deeper.